Today's lesson is about even and odd functions. Let's look at the following functions. We have y equals x squared, x to the fourth power, x to the sixth power, and so on. This kind of function, look at the graph. They are reflecting across the y-axis. Also, for this kind of function has the following property. We know any point on the graph, let's label as x, y, and we do have a negative x, y. In other words, we could say f of x equals y, and f of negative x equals y. So f of negative x equals f of x. For all functions, if the graph reflect across y-axis, or for all the functions, they have this property, f of negative x equals f of x. We call this is an even function. Compared to even functions, we have odd functions. Look at the following functions. Y equals x to the first power, y equals x third power, y equals x to the fifth power, and so on. You could say the graph of x to the 2n minus 1th power. This is an odd power. All the graph reflect across the origin. And also for this kind of function has the following property. This is x, y on the graph of any odd function. Then negative x, negative y is also on the graph. So we have f of x equals y. F of negative x equals negative y. Then we multiply by negative 1 here. You could say f of negative x equals negative f of x. In other words, for those functions whose graph reflect across the origin, or f of negative x equals negative f of x, are odd functions. Now you are given 3 graphs. You can check which one is even or odd or neither. We check the graph is it reflect across the y-axis. This function reflect across y-axis. And this function reflect across the origin. Or you could see symmetric across origin. Then this will be even function. And this is an odd function. Look at the middle graph. It's not reflect across y-axis. It's not reflect across the origin. That's why this one is neither. For today's class, we will algebraically prove whether the function is even, odd, or neither. This is the formula for you to remember. If f of negative x equals fx, we call this is an even function. The graph will be reflected across the y-axis. If f of negative x equals negative fx, then this function will be odd function, and it's reflected across the origin. So what's the meaning for f of negative x? That means for every single x, change into negative x. What's the meaning for this negative f of x? That's the opposite of fx.
In other words, you could say that means -1 times f of x. For fraction, opposite of a fraction like a over b, opposite, it will be -a over b. In other words, only your numerator change the sign, your denominator stay the same for fraction. Here's some rules for negative x. When negative x to the evens power, and you will get the x to the even numbers power. If negative x to the odd numbers power, you will get the negative sign, then x to the odd numbers power. How to understand this easily? Think about negative sign now. We know negative sign square, that's a positive. While you do negative sign to the fourth power, you get the positive. When negative sign to the third power, that's a negative. And negative sign to the fifth power, that's a negative. In other words, when negative sign to the even numbers power, we got positive. And a negative sign to the odd numbers power, we got the negative. Therefore, when we have negative x squared, you will get negative sign squared, that's positive. Then x squared, that's x squared. Normally, the positive sign we don't write. Then do one more. Negative x to the fourth power. Negative x to fourth power is positive. We don't write down. But x to the fourth power, write down x to the fourth power. Now let's go to this one. If I have negative x to the third power, you know that negative sign to third power, that's negative. And x to the third power, I just write down x to the third power. Then we have negative x to the fifth power. You do separately. What's the negative sign to the fifth power? That's negative. X to the fifth power will be negative x to the fifth power. Since we know that absolute value of -2 equals +2, therefore absolute value of negative x equals absolute value of x. Now look at some examples. Determine whether each function is even, odd, or neither algebraically. If odd or even, describe the symmetric of the graph of the function. Here is the hint. Even function, you have to have this pattern. For odd function, you have this pattern. First of all, I will work on negative fx. That means opposite of fx, which means each term get opposite. Since I have x squared, that's opposite is negative x squared. Positive 8x, that's negative 8x. Negative 14, that's positive 14. Then I'm working on f of negative x. The meaning for f of negative x is to change every single x into negative x. Therefore, I plug in, change every single x into negative x. Then plus 8 times negative x minus 14. Then work parentheses out. While you have negative x squared, that's x squared. 8 times negative 8, that means minus 8x minus 14. Then you need to compare to the original function, f of x. You could say f of negative x is not equal to fx. And it's not equal to negative fx. Therefore, this function is neither. Now let's go to number 5. First of all, still, I need a negative h of x. Since this is a fraction, you get the opposite of a numerator. That's how you get the positive x to the third power. Denominator stay the same like this. Then we work on h of negative x, which means for every single x turning into negative x. So we got negative, then negative x to the third power. We have 3 times negative x squared minus 9. Let's work out negative x to the third power and negative x to the fourth power. First of all, we're working on the exponents first. Therefore, negative sign to the third power is still negative. X third power is x third power. So you get a negative is a positive x to the third power. For this one, we have negative sign to the fourth power, that's positive. And x to the fourth power is a fourth power. So negative times a positive is a negative x to the fourth power. Therefore, for negative x to the third power, that is negative x to the third power. And negative x squared, that's x squared. Therefore, we got negative, that's positive x third power. Denominator, we got 3x squared minus 9. When you check back, you could say h of negative x equals negative h of x. So it is an odd function and reflect across the origin. Now let's go to number 7. Still, I need to work out opposite of fx. That's the opposite of this x will be negative x. Opposite of a negative absolute value of x means positive absolute value of x. So we got the f of negative x now. F of negative x means we need to plug every single x into negative x. So we got the negative x minus absolute value of negative x. We get rid of the parentheses. You get the absolute value of negative x is the absolute value of positive x. Then we check back. You could say it's not equal to fx and it's not equal to negative fx. Therefore, it's neither. Now let's go to number 9. First of all, we work out negative fx. That is negative cosine x. F of negative x, we change every single x into negative x. According to the even odd formula for trig function, we know this is a cosine x. Therefore, it is equals f of x. So, it is even. It will be reflected across the y-axis. Now go to number 6. We got the negative fx equals negative cubic root of 2x squared minus x to the fourth power. And f of negative x equals, change every single x into negative x. So we got the 2 negative x squared minus negative x to the fourth power. Then we work out this negative x squared, that is x squared. Negative x to the fourth power, that's x to the fourth power. Therefore, we got cubic root of 2x squared minus x to the fourth power. That's equals to the original function. Therefore, it is an even function. And the graph is reflected across the y-axis.